Sorry, hear me all right? Cool. All right, well, thanks to PIANC and Rena, to Jim for having us here today. My name's Matt McGellin. I'm a lead project engineer, naval architect at Fortescue. For those of you who don't know, there's probably no one in the room who doesn't, but maybe online. Fortescue is a mining and energy company, first and foremost, with a mandate to decarbonise our own operations by 2030. What you might not know about Fortescue is that we also own some of our own ore carriers. We're also a shipper, small scale in the scheme of things, but we do own our own vessels, so they form part of our own emissions. It's a legal boilerplate for you. So what is a Green Pioneer? The Green Pioneer is the world's first ammonia-powered ship. Formerly was a platform supply vessel and has been fully converted into a technology demonstrator. It's got full class and flag state approval. It's registered and able to sail anywhere in the world. Was retrofitted over a course of 6 months after about an 18-month design cycle. And we completed the world's first and second ammonia bunkering in Singapore with the support of Singapore MPA. Why is it significant? A lot of the groups and probably a lot of the people here tonight will have a vested interest and be working on one of these areas. But typically when you go to people, they say, oh, I can't build my ship because there's no fuel. And you go to the fuel suppliers and say, I can't supply fuel because there's no bunkering regulation. You go to the governments and ask them why there's no bunkering regulation. They tell you there's no demand from the shippers. So what Fortescue's done, and this may be a Fortescue specialty, is kind of a different approach, and this a make it happen attitude. And by, I guess, forging ahead regardless and pushing this project through, I think we've demonstrated demand. We've conducted these bunkering operations. When we started the project, we spoke to engine manufacturers who told us there wouldn't be an ammonia engine on the market until 2031, which for us, decarbonise by 2030, that doesn't work. So we set out to do it ourselves. And what do you know? This year, there's ammonia engines on the market. It's nothing like a bit of friendly competition to get people going, right? So yeah, by, I guess, doing all these things all at once, a lot of work and a lot of moving parts, but it lets us bring everyone to the table around a common project. So yes, we're going to do this. How do we make it happen instead of just constantly passing the buck? So this is where we go maybe into a little bit more technical detail. And I apologize to anyone who is violently uninterested, but this is a Green Pioneer, and this is an overview. So we have obviously an integrated fuel control system. The whole system can be purged through with nitrogen. At the stern of the ship, we've got the ammonia fuel delivery system and our ammonia storage tank, and obviously the vent mask where all our purge goes through. From the ammonia tank, stern of the ship, fuel is fed through into heat exchangers, which effectively heat the fuel up, so it remains in a higher pressure gaseous state. That is then fed forward along dual wall piping, so it's 2 sets of containment, to 2 gas valve units, which effectively meter and regulate the flow, take that higher pressure gas and step it down to something which is close to what the engines can take. From there, it's fed through the engine gas valve units, and where we do our final throttle control, and into the engines, where it's burned in conjunction with HBO biofuels, a pilot. From there, obviously the fuel's combusted, we take power out, and we have in the exhaust stream SCRs, which help us to treat our NOx emissions, which I know a lot of people tend to be quite concerned about with ammonia. In our experience, because we have established technology for NOx scrubbing, it's not really as much of an issue as people tend to make out. So challenges, and this is where we get really into the weeds. So again, I apologise. First of all, we've got release safety. And this is a very big topic and something which was originally supposed to be a 45-minute presentation. So I've cut a lot out of this and picked one of these topics to really drill into. But it's important to remember that for these systems, an integrated approach and a really robust safety concept going in is very important. So when you're developing the systems for the naval architects, the engineers in the room, having some prior planning and some understanding of what you're doing and what the fuel is like going in and how it behaves really will pay off in the long term. Now, the one which I've chosen to speak about a little bit more is dispersion. Dispersion tends to get thrown around a lot as like a buzzword. People want to see dispersion analysis. You talk to anyone, they want to see a dispersion analysis. And dispersion analysis are fantastic, but don't fall for the hype and the buzzwords. Unless you really know what you're doing and you understand your inputs and your outputs and understand your system, they're only as good as the paper they're written on. But they do have a significant impact on vessel design. So where you place your vents and ammonia vents and ammonia systems in relation to especially accommodation, crew quarters, air intakes, access and egress, life craft, that kind of thing, all very important in relation to emergency sort of scenarios. For the Green Pioneer specifically, this is just a little taste of what it might look like. This is a dispersion analysis output, artist impression, of an AGL3, which is a 2700 ppm for those who care, contour, released from a pressure relief valve on the ammonia tank. It's our worst case scenario on the ship. And you can see in this that there is no interaction with the vessel accommodation or other parts of the vessel. Generally, these dispersion events can be sort of managed within the length of the vessel, and that's kind of one of our key learnings. With the right safety systems, you can really keep it within the footprint or within the length of the vessel. Another technical challenge we had, there's three, fire safety. There's a little bit of, everyone loves an explosion. Ammonia at the top and you've got LNG on the bottom. People tend to lump these two fuels into the same category. All the rules and regulations that apply to LNG get chucked onto ammonia as well. But you can really see ammonia pool fires, it won't burn in a pool on a deck. It won't burn as a gas in the air because it tends to be buoyant and will just float away. Whereas LNG, put a match to it and it will burn. That's not to say the flammability risk doesn't exist. A stoichiometric ratio will burn like in an engine, but open fires on open deck are really not a credible case. This is another example. These are real time, by the way, of an LNG stoichiometric ratio burning versus an ammonia. And you can really see in the ammonia one, the shockwave from the ammonia flame extinguishes the second half of that covered I guess test apparatus. Final challenge, and this one's a really big one, is the regulatory side. And I apologize, there's no fun animations on this one, just a wall of text, because I had to deal with a much bigger wall of text when we went into these regulations. When we started the project, there were no published IMO guidelines for ammonia-powered ships. Now, or very soon, there will be, but they're not perfect. There's still a lot of risk-based elements in that design. And risk-based design tools are excellent and have prevented a lot of incidents in the past, but they do come with a couple of caveats. If you don't really understand what you're doing and take the time up front to understand the challenges, and in the case of ammonia, really understand the fuel, like in the two examples we just saw, you're going to end up going down costly and wasting a lot of time going down these rabbit holes where really there's no need to. Our experience aboard the ship, I've been on board the ship and a couple of my colleagues here have, is that it really is a safe fuel. I think we have, as an operator and having worked on these ships, we have a very different perspective, and hopefully we can share that perspective with you. Yeah, thanks. If you want to get in touch, don't do business cards, paper, no good. So if you want to get in touch, please scan the QR code, and we can chat later. Thank you.